Hello, now we start talking a little bit about verification and validation of software. This is an important area when you develop software because it is where you verify and validate whether what the software artifact we have produced is according to the expectations and the specifications. Okay, so it's quite important. It takes a long time during software development. In the past, it used to occur only in the last phases of the development of the artifact. Currently, something that occurs from the beginning, and is a concern from the beginning, and more techniques try to help in the verification and the validation of software from the very beginning. Okay. So what I'm going to address first is to understand why software has bugs. Okay, may seems not nothing special, pretty obvious, but I think there are some points that are relevant to understand where are the difficulties about verifying and validating software. Okay, so as you may expect, the cause of bugs in software is because humans make errors, right? And humans make errors, and during their activities, usually they do not perform completely in a way completely correct. So there are so many reasons why humans basically do something wrong, and they are able to correct their behavior. But when they write it in software, then what happens is that this software, when it's going to be executed by the computer, okay, that then you just find the bug there, okay. And so, but let's understand what is more or less the life cycle of a bug or an error. So basically, you have a human error, okay? So because the person is absent-minded, or is stressed, or is at the end of the day, or there are many reasons, or the problem is too difficult, and because of that, they basically create a fault, okay? And a fault is a defect in the software, okay? But the fault is there, and it's no problem until it basically generates errors. So what's going to happen is that the software starts executing. In some point, because of this fault, the behavior of the program changes. So it's not the expected behavior, and the behavior changes. And this is an error when the behavior changes. And what happens is that usually this behavior is not visible, necessarily visible. It's an internal behavior that is hidden inside the execution of the program. And these errors basically generate changes in other behavior of the program. And in some point, this behavior becomes visible. Well, when this behavior becomes visible, so we call that this error is a failure. And usually what we call a bug. A bug is basically, yes, we now discover that the program is not functioning correctly, right? So what's going to happen now and is that what is visible for the developer that is verifying the program or validating the program is that actually they see a failure, but what they ask is, what is the fault? And so, debugging, we can say that is basically going from failures back to the faults, back to the origin of the wrong behavior. And what makes basically debugging difficult, as you may know, is not to correct the fault. Most of the cases, the fault is quite obviously not always, but most of the time it's quite obvious to correct it. It's basically to detect, to identify the fault. And something that is relevant when you do verification and validation of programs is that this is more difficult if this distance is bigger. Why? If conceptually in your mind, by looking at the failure, you cannot understand what is the fault. And this distance is because of two reasons. The first one is if it was a long time ago that you introduced the fault in the code, when you see the failure, it's very difficult to relate with that because there are so many changing since the last time, since you introduced the fault. So that's one reason why it's very good so that you keep testing your program, because if you keep testing your program, you reduce this distance. So this time since it was created, you reduce it. Why do you reduce it? You reduce it basically because, yes, I just run my tests and the system is working, then I change a little bit my code, I ran the tests, and I got a failure. And if I got a failure, well, then it means that it was because of the last changes. Okay? Then there are other reasons why this distance can be big. Is if the number of errors that occur since the fault, then if there is a big number of errors, it means that when you look at the failure, it's very difficult to understand. So it's actually looking at this behavior and understand the reason because the behavior is changed. A good example of it is a memory leak. So you get an out of memory, and it's very difficult to understand where is the fault because actually there are so many errors in between that is very difficult to debug. Okay, so I think that it gives you a good hint about some of the qualities related with the tools and the techniques that you should use in order to debug and verify programs. And I think that these qualities should be all the techniques, okay, and all the methods and all the tools that deal with the reduction of this distance between the failure and the fault. They can be quite helpful, okay? Then something happens after. After you get the failure and you identify the fault, you can basically reason about what is happening here. And you can see what is the cause and identify human error. And this is usually a very good behavior, something very good to do, because from this human error, you may say that probably this is a standard behavior, not only of this element of the team, but sometimes of the team itself. In that case, you basically infer more faults, and it helps to infer more faults. So it's very nice to identify the cause of the faults, not the fault itself, but the human error that is behind the fault. Okay? So, human error, a human action which produces software faults, fault, an omission, a defect in the software cause of a human error, an unexpected behavior in the system, unexpected change in the system behavior caused by a fault, and failure, an observed error. Okay, see you in a while.